A very good morning, students. In the last lecture, we have derived Bernoulli's equation from Euler's equation of motion. In today's class, we will see the practical applications of Bernoulli's equation. Practically, Bernoulli's equation is applied to incompressible flow, steady flow, and ideal fluid. So we could have seen the assumptions of Bernoulli's equation, and its applications are in venturi meter, orifice meter, pitot tube, and nozzle. So these instruments are used for finding rate of discharge through a pipe in a chemical industry or any industries, so through which either a liquid or gas is flowing. Venturi meter. It is an instrument which is used to measure the rate of discharge in a pipeline and is often fixed permanently at different sections of pipeline to measure the discharge through the pipe. So it has three parts. One is converging part, section 1 you can see in this figure, and section 2 is throat, and then it is diverging. So these are the three parts of the venturi meter. The basic principle is that by reducing the cross-sectional area of a flow passage, the pressure difference is created. The measurement of pressure difference enables the determination of discharge through pipes. So for example, we could connect the U-tube manometer or a differential manometer at the converging part or section 1, and one end is connected to the throat. So it consists of three parts: an inlet section followed by a convergent cone. The inlet section of the venturi meter is of same diameter as that of pipe. Followed by a convergent cone. The convergent cone is a short pipe that tapers from the original size to that of the throat of venturi meter. It has an included angle of 21 degree plus or minus 10 degree, approximately 2.7 diameter ratio, parallel to the axis, where D is the diameter of the inlet section and small d is the diameter of the throat. A cylindrical throat. Throat of the venturi meter is a short parallel side tube having its cross-sectional area smaller than that of the pipe. Then the third part is a gradually divergent cone. A divergent cone is gradually a diverging pipe with its cross-sectional area increasing from that of throat to the original size of the pipe. The total included angle in this cone is between 5 to 8. Length of the cone is 7.5 diameter, such that the length convergent cone to be smaller than the divergent part. The pressure measuring systems such as manometer is mounted to measure the pressure difference in the inlet section and the throat. So one limb of the convergence, one limb of the manometer is connected to the section 1, that is convergent part, and another limb of the manometer is connected to the throat, so that is section 2. So mathematically, venturi meter fitted in a horizontal pipe through which a fluid is flowing as water. If the fluid is incompressible with no loss of energy between the section 1 and 2, the Bernoulli's equation can be written as P1 by rho plus V1 square by 2G plus Z1. Similarly, P2 by gamma plus V2 square by 2G plus Z. So if the venturi meter is connected in a horizontal pipe, so then the datum weight is 0. Z1 is equal to Z2 equal to 0. So the above equation is reduces to P1 gamma plus V1 square by 2G equal to P2 gamma plus V2 square by 2G. So again the equation is rewritten as P1 gamma minus P2 gamma equal to V2 square by 2G minus V1 square by 2G. So P1 gamma minus P2 gamma is the difference between the pressure head at section 1 and section 2, which is known as venturi head. That can be written as H, small h. Then the Q theoretical is the discharge through the pipe. So that can be written by using continuity equation. Q is equal to A1 V1 is equal to A2 V2 at section 2. So from that, so we can write Q theoretical is equal to A1 A2 root 2 GH by A1 square minus A2 square. The actual discharge may be obtained by multiplying the theoretical discharge by a factor CD, which is called coefficient of discharge, or CD is equal to actual discharge by theoretical discharge. So actual discharge can be calculated by AH by T, where area is the collection tank and H is the height of 10 centimeter rise and time taken for 10 centimeter rise. Thank you.